Now, today I want to essentially go back to a topic that's been recurring throughout this module, and that's automated testing. So if you go into Moodle and you go into the automated testing section, then you'll see a new set of slides titled Web API Testing. So at this stage now, we've looked at unit testing, end-to-end testing, and now we're going to look at API testing. I guess in real life, the way you kind of sequence these things are unit testing first, web API testing next, and then end-to-end testing. But the reason I didn't do them in that order was mainly because of the way the web app dev module is sequenced. Okay, so I'm going to work my way through these slides. Now, a lot of the issues are repeating from before, so technically this should be a fairly straightforward. In terms of comprehension, it's going to be straightforward enough for you. The only slight challenge will be how we write the tests, but it's still going to be back to Mocha and Chai, which we're very familiar with. Okay, but before I get into that, let's set the scene. Just give me 1 minute. So these are the slides that I want to walk my way through. Okay, so web API testing, obviously it's specific to web apps, but it's kind of comparable to what we might have called integration testing in days gone by, or subsystem testing is a more generic name, maybe. Kind of falls into that category. And so the API, the web API, that's now our test target. It's a term I've used before, Witchy. Also, we regard the API, or we kind of view it as a black box, which is an analogy that I've mentioned in relation to end-to-end testing. So in this case, our black box is the web API. We know how to provide input to it. We make HTTP requests. We know what the API endpoint does. We get that from a specification. And we know what the response, the HTTP response should be from a particular endpoint request. All of that detail is in the specification. We're not concerned with the detail of how the web API works internally. Again, that is something that we would be interested when we were doing unit testing. So we view our black box as consisting of an interface, which in this case is a HTTP interface with endpoints, and it has a specification. And we state our expectations, and we know what that means now in relation to testing. We state expectations around the HTTP response that we get back from a particular endpoint request. I'm also saying over here that we are possibly interested in some side effects of a particular request as well. In particular, if the API is talking to a database and a particular request should cause a change to happen in the database, that's what I mean by a side effect, then we're possibly interested in ensuring that those side effects do actually occur. Right, they're the two essential points from that slide. In terms of testing principles, it's all the same stuff that we already know about. So we're also interested in looking at designing normal test cases, exceptional boundary test cases and error test cases. That terminology makes sense in relation to a web API target as well. So all of that we've learned in relation to those can be reapplied. This whole given, when, then way of thinking about what are the different test cases that I need to come up with, that approach can be used for web API testing as well, or any type of testing, automated testing when it comes to it. Just give you an example here, which you can read yourselves. Test isolation, we're going to have a number of test cases, and we want to ensure that each test case runs in isolation. So that's still an important principle. This one here about making sure not only are your tests concerned with ensuring that the target, the web API, returns the right response, we're also interested in ensuring that the state that is being managed by the web API has been changed if it should be changed. Now, state in this case translates directly to whatever your persistence layer is, which typically is a database. And I've already mentioned that in relation to side effects earlier on. And finally, the silent principle applies here as well. Don't have your test outputting lots of console logs or whatever the equivalent is in whatever language you're using. All we want to know is, did the test pass? Kind of yes or no. And if it didn't pass, which particular test failed and why? Not so much why did it fail, but what was my expected response or result, and what was the actual result? I just want to know those two things. So that's the only output that we should be getting from our tests. I'm just listing then some of the kind of, in terms of expectations, you might be making writing statements that are expressing some of the expectations that I'm listing here, and they reflect the fact that our target now is a web API. So you might have an expectation that states, well, was the HTTP status response 200 or whatever I expected it to be? Could be a 404, could be a 300 error response. Sometimes you may be interested in checking that the response from a web API contained particular headers, HTTP headers, and those headers had specific values associated with them. That may be important. It might be that fine-grained. So I'm just mentioning one of the response headers, the content type header, for example. We're not necessarily interested in that level in this module, but certainly there's status code response. We would be stating expectations around that. Other examples are, you see, obviously in the majority of cases, the HTTP response will contain a body, and that body will typically be JSON, although it doesn't have to be. So we might want to be able to make statements about the structure of the JSON that's coming back, which is what I mean by the schema there. We may be interested in, is response payload valid? Well, that's a very generic thing, but that kind of overlaps with the one above it, really, in a sense. And maybe you're not just interested in this in the structure, but you're also interested in the detail within that structure. So you may be interested in making expectation statements about specific key value pairs in the HTTP response body that comes back. Okay, so there are just all some examples of the types of statements, expectation statements that we hopefully will be able to encode in whatever testing framework that we use. Clearly, the difference between unit testing and web API testing is the fact that your target now is remote. It's running on a remote server, whether that even be localhost. It's still running on a server that's remote from the test code itself, if you like. So there's an asynchronous behavior aspect to our tests, and I'm saying that the testing framework, which in our case actually will be Mocha, the testing framework has to kind of wait for the HTTP response to come back before it evaluates its expectation statements. That wasn't an issue with the unit testing for sure, because we were communicating synchronously. But it is a concern here. Now, as I've mentioned in relation to Cypress, hopefully that's kind of built into the framework that we don't have to do too much low-level coding to take care of the asynchronous nature of the communication. But it's something we need to be aware of anyway. Now, I'm just showing you, here is an outline using Mocha, because we will be using Mocha. This is an outline of what a typical test case will be for our web API. So we're going to have our describe blocks and init blocks as before. And then inside an init block, here is where we're going to be sending requests, HTTP requests to our web API. Eventually, it will respond back. And then we make our expectation statements, Then we make our expectation statements around the response that came back. But there is a delay between this here and here. That's natural to the target. Now, there's just something about Mocha that we need to be aware of. And so I'm explaining it in steps first. If we just take this, if we just forget about web APIs for the moment, I'm just making a statement here, which is true about Mocha, which is that if you've got an empty test, and by empty, I mean there are no expectation statements. You can have any code you want to in here. You could be talking to your target, whatever the target is. But if there are no expectation statements in your it block, then by default, that test is categorized as having passed from Mocha's point of view, which makes sense, I guess. Now, supposing here's a kind of an artificial example of an asynchronous target. Now, I'm not actually using a web API. I'm just using the JavaScript set timeout function, which I'm sure you're all aware of. You know the set timeout function. What you do is you pass it a callback, and you also pass it a delay period in milliseconds. And the way the set timeout works, as you know, is it will invoke this callback after this period of time has elapsed. So that's really a very simple example of an asynchronous piece of code. And I've got an expectation statement, and we're familiar with this syntax now from earlier on in the module. I've got an expectation statement inside in my code, which is going to run sometime in the future. It's not going to run immediately. It's going to run sometime in the future. And we can see from the specifics of it, I've got a variable here called foo, which I've initialized to false. And my expectation statement is evaluating foo. And it's saying it's expecting it to equal true. Now, clearly, this expectation statement is going to, well, it should fail because I've set it to false. I'm now evaluating to check that it's true. And we can assume there's nothing in between that has caused it to change to true. So you'd imagine that this particular test case would fail because I have an expectation statement that fails. But in fact, it's going to pass. And the reason it passes is because Mocha does not wait, Mocha does not wait for it doesn't wait for asynchronous code to complete execution before it outputs to the terminal, before it outputs the result of the test to the terminal. It doesn't wait. Therefore, the way Mocha executes this is it starts executing this it block, and if there was code here, it would execute that. And then when it's finished the it block, it doesn't wait around for this callback to execute now. It's gotten to the end of the it block. This code hasn't executed yet, though. It's gotten to the end of the it block. It has come across no expectation statement that has failed. In other words, essentially, this applies up here. It's an empty test case. And because it's an empty test case, then by default, it says, okay, this test case has passed. And it outputs that result out to the screen or to the terminal. And that's why this asynchronous, albeit somewhat artificial, this asynchronous test isn't actually giving me the result I expected it to give me. So how do we overcome that problem? And there is a solution built into Mocha, not surprisingly. So there's this special callback function called, you can actually call it anything you want to, but the convention is to call it the done callback function. And it's actually implemented internally within Mocha itself. So here I'm setting, kind of repeating, I'm setting by default, Mocha does not wait for asynchronous targets, okay? Expectations are evaluated. Yeah, any expectation statements that you have inside in your asynchronous code, those expectation statements, they are evaluated, but they're kind of evaluated too late. They're evaluated after Mocha has already outputted a response back to the terminal, which is too late. However, I'm saying we can force Mocha to wait for our asynchronous code using this special done function. And so here's how you code it. So here's my exact same example, but you can see here I'm passing an argument to the second argument of the it block, okay? And Mocha will actually assign a value to this argument, and what it assigns to it is a special function that it has implemented internally. And this special function, the role it has is Mocha will not output a result out to the terminal until this special function has been explicitly invoked within your code. And you can see down here, I'm actually invoking or calling this special function after my expectation statement. So now the way this test case runs is Mocha begins and it executes whatever code is in here. There isn't any right now. It then executes the set timeout, and then it waits for 4,000 milliseconds. But because I have asked Mocha to inject or pass in this special done function into my callback here, then Mocha knows it must wait until done has been called before it should output a response back to the terminal. And so now it waits, and eventually this code executes after 4,000 milliseconds. 400 milliseconds have elapsed. It evaluates the expectation statement. Now that expectation statement is going to result in a failed test, and it builds the response that it wants to output to the terminal. And then eventually I invoke this special function that Mocha has provided me with. And after invoking that, it now outputs to the terminal. And so this time it will work successfully in the sense that it'll tell me your test has failed. So this is the way I kind of tell Mocha to wait until any asynchronous code has been executed. Essentially, all I'm saying to Mocha is don't output anything to the terminal until this special function has been invoked. And that would apply irrespective of whether I had asynchronous code in here or not. We could have used this when we were doing unit testing, but we didn't need to because our unit tests were synchronous. And this works whether your test passes or succeeds. So on this example over here, I'm initializing foo to true. I'm evaluating here, is it equal to true? So this test will pass as we'd expect it to. This test will fail as we'd expect it to. So both of them work properly for me. I don't know why that keeps jumping in me, sorry. Okay, so that's how we get Mocha to essentially play properly with asynchronous code, which would be web APIs in our sense, in our case. There's a second thing about Mocha we need to be aware of, and that is, okay, yeah, I'm telling you from the previous screen that Mocha waits until the done function has been called, but it won't wait forever. Okay, there is eventually it'll time out. And so there is a default timeout period for Mocha, although you can configure it to be something other than the default. So in this example here, I'm saying that this test should pass, but in fact it won't. And so here I'm my set timeout is saying wait 4,000 milliseconds. Now the default timeout is 2,000 milliseconds. So in this case, Mocha will not wait until the done function has been called, because after 2,000 milliseconds has elapsed, it essentially gives up, and it will report back to the terminal, and in that case, it won't have evaluated this expectation statement here. And so we're back to where we began, which is this it block has no expectation statement that it has evaluated in time before the timeout expired. And that means this overall test is going to pass. And should it have passed, foo set to false? I'm checking to see if it's false. Well, it should have, it will pass as it turns out, but it's only passing. Oh, sorry, I beg your pardon. No, sorry. Let me rewind on that. Sorry, let's go back a little bit now, actually. So I'm telling it here, wait 4,000 milliseconds before you execute this code. But the default timeout period for Mocha is 2,000 milliseconds. And so after 2,000 milliseconds has elapsed, Mocha will report back to the terminal at that stage, and it will tell you it has timed out. So it won't tell you whether the test failed or passed. It'll just tell you it timed out for one of its test cases, this test case in this case. It was asked to wait, but it couldn't wait for the period that I asked it to, which was 4,000 milliseconds. So it never gets to execute this. It never gets to execute this. It just times out before all of that. So you get this kind of response back from it. 0 passes, 1 failed. Look, it seems to default to, well, if I couldn't evaluate all of the tests, then I'm assuming that some of them have failed. I think that looks like the default approach it takes to this. But this is the important part of the response. It's actually telling you the reason it failed really is for timeout purposes. It's not that one of your expectation statements evaluated to false. So we need to be aware of this 2,000 millisecond timeout period associated with Mocha. And so if you are testing a web API and for whatever reason you're testing it on a slow network, then you may need to reconfigure Mocha to use a longer timeout period. That's essentially what we're getting at here. And you can do that from the command line. This thing keeps jumping. Sorry, no. You can do that from the command line by just setting it like this. Or you can use a Mocha configuration file, which I'll show you how to use in the labs, and set the timeout in that as well. But that really only applies if you're testing a web API, which you know will need more than 2000 milliseconds to respond back to you, which I don't think will really arise in your case, but right. As have already indicated now, we are going to be using Mocha as our testing framework. We're going to use a new framework called, well, it's a library really rather than a framework, I suppose. It's probably somewhere halfway between a framework and a library, called Supertest. And Supertest is going to act as our HTTP client. So it will make writing HTTP requests within our Mocha code easier. And it also has a built-in expectation library part to it. And the expectation library makes it easy for us to express the kind of expectations that I mentioned there a couple of slides back, like checking to see, is the HTTP response one of the codes you expected it to be? Does the response contain a particular header, and does that header have a particular value? All of those types of expectations are easy enough to express using this special expectation library that's built into Supertest. And we'll be using Chai as well. Chai will allow us to do more fine-grained expectation statements around essentially kind of the body of the response, the HTTP response that comes back. So here's an example of using essentially the Supertest library. And okay, so I'm importing, there's a special function, I guess, called request that's provided by the Supertest library. And what you'll also do in your test cases, now I've left out the Mocha, the describe blocks, init blocks. You can imagine that they wrap this stuff, but for clarity, I've left those out. But you'll also be importing the actual API itself. So that's going to be importing the module in your code that implements the web API, which in your case is an Express API. Again, yeah, I'll give you a little bit more detail on that in the library, but for now, we can just say that this variable here, API, that's going to be our reference to our web API. And so the way you code the request function is you pass it a reference to the web API, and then you use this method chaining programming technique, which is what I'm doing here. The first parts of the method chain is here. I'm just saying, what type of HTTP request do I want the Supertest to generate for me? And so here I'm telling it generate a HTTP GET request. And here is the endpoint of the GET request. The set here is allowing me to set request headers, HTTP request headers. Some web APIs may require you to have particular HTTP request headers in your requests. So you need to be able to initialize those headers, and that's what this set method allows you to do. So this particular example, it looks like I'm setting the accept request header, and I'm setting it to this value. And you can have other invocations of set chained on here. So there may be a number of headers that you have to set, and you can just go .set, .set, .set. Eventually, we start reaching the expectation part of our code. And here this expectation statement is simply checking to see that the response was a 200 status response. And you can have other expectation statements chained on here, which might be interested in looking at HTTP response headers. The very last method in this chain of methods is the end method. And the end method is past a callback. And that callback, as its arguments, will include the error response if there is an error response from the web API, or alternatively, the actual valid HTTP response. So it'll be one or the other typically. Now, inside in this callback is where you would put, using the child library, you'd put actual expectation statements, which would be examining the body of the response. So you can just do response resp.body, where resp is this argument here. So this expression resp.body, that will evaluate to the JSON data structure that comes back in the HTTP response. And you can write whatever expectation statements you want to around that, typically using the child library. So the expectation statements that we have here, there's too much stuff now appearing on that screen. The expectation statements that we have here are provided by the supertest library, whereas the expectation statements that we have here, we would tend to use the child library. And so this is going to be this is essentially going to be contained within an it block of your test suite. Here's an example of a HTTP post request using the supertest library. So again, it's request, the reference to the actual web API. This time I'm using the post method as opposed to get because it's a post request. Here's the endpoint path name. Then the send method is where you would put the JSON object that you want to include with the post. So it's the payload for the post, if you like. And then you have, again, your expectation statements around the response. Typically, a post request returns a 201, although it doesn't have to. The last method, as always, is the end method in this chain of methods. And we know now what we would put inside in the end method here. We would put expectation statements based on what we expected the payload in the response from our post request to be. In some cases, typically, I suppose it would be when your request returns some sort of, maybe I'll call it an error message, but it's an error message that you've programmed into the web API. And in those kind of cases, typically the response that comes back is a standard response that you've programmed, as opposed to, you know, this example here where the body of the response, where the body of the response is a fairly non-trivial JSON data structure, and you want to, like, let's say it could be an array of 20 movies, okay, and you want to do some fairly detailed examination of that array of 20 movies. Whereas in this example, and if I stick with the what I'm trying to illustrate here, actually, which one is it? This one. Sorry, now just give me 1 second. Is this the right one? Sorry, no, I've just lost. Let me go back. I've lost my trail of thought there now. That's okay. That's a post. Oh yeah, okay. Yeah, I mean, all I'm illustrating here is some examples of what might go in the callback that you pass to the end method. And so if we take the particular example, and obviously this is kind of based on what you're doing in the web app dev module, But if we send a get API/movies request to our movies web API, and let's supposing we know based on the specification that this request should return an array of 20 movies. And inside here then is where I'm examining that data that's coming back. So it looks like I'm checking to see is response.body.movies, is that an array? And does the array have length 20? And you might even go into more detail about other particular movies within the array. Oh yeah, sorry, I see what I'm doing here now, actually. Of course, the very last statement inside in this callback is our friend, the done method, because I have passed in done here into the second argument of the it block. I've kind of conveniently ignored that in the previous couple of slides. But because now this request is inside an it block, then all of the arguments that I was making earlier on apply. So we've got to ensure that Mocha waits until my web API does actually respond back with a response, and I can evaluate the contents of the response, and only then should Mocha report back to the terminal as to what the result of this overall test was. And so here comes my done method that I'm passing in, and here at the very end, oh gosh, I don't know why that keeps jumping. Sorry now. Sorry. That's why the very last statement has to be done. An invocation of done. Right. If the response for a particular request, so maybe if we look at the exam, the what was in my mind when I was writing this. So supposing we do a get request to our movies web API, and we're looking for the movie with the ID 9999, knowing that that is actually an invalid movie ID. So behind the scenes, the web API would send a request to the database, or even to TMDB, and we'd get an record not found if it was a database, or some sort of error message from TMDB, and we just want to report that back to the client. So there's no sophisticated payload coming back from this request. There's a sort of a standard message coming back. And so in that case, you can evaluate or examine the message using a standard expect invocation. You don't need to use the more sophisticated detail that I had on the previous screen. Like, you don't need all of this stuff at all. So if the response back from a particular request is typically some sort of standard message from the web API, then you can actually pass the structure of the message to an invocation of super test expect statements. This is not a chai one now, this is a super test one. And so we expect it to return something, a JSON structure that's as simple as this. It contains a message key, and it contains that actual text in the message. And again, you would get that from the specification for this particular web API. You, of course, do have to invoke done. So this code here, if you can kind of follow the pattern, right? This here is a callback. I can draw it well. This is a callback, but it's the second argument to this method call, or this function call. Slightly clumsy coding, but that's what you have to do. So again, this is when essentially, I guess I would say this, you would use this style when you're doing some error checking of your web API, and you're checking to make sure that the web API does respond with an appropriate error message with particular text in that error message. You can also use a promise-based programming style with supertest, and that's what I'm doing here. So when you're using the promise-based programming style, you don't need the done function at all. It's kind of built into the promised programming model. So again, we're using the request function provided by supertest, but notice I'm returning whatever request returns, or more specifically, whatever this chain of methods return. When you're using the promise-based programming model, all of this looks just the same as before. Okay, that's all the same as before. The only thing that's different is we're using the then method as opposed to the end method. And you're familiar with the promise-based programming style for asynchronous communication and the role of then. So the then now is being used, and the then method expects a callback, and that's what I'm giving it here. I'm giving a callback. The callback, as it takes one argument, and it's going to be the body of the response that comes back from the HTTP request. And as before, inside here, you can have your chai expectation statements evaluating the body of the response. So there's no done method. There's no invocation of done. I'm not passing done in here at all. Okay. And that, I guess we would say this is a slightly cleaner approach towards ensuring that Mocha waits for our asynchronous target to respond back. So it's either this approach or, this approach where we're using done. And in fairness, I think you'd agree that this is a cleaner programming model. In next week's lab, you'll get a chance to use both of them. But in terms of an assignment, and second assignment will be around doing some testing of your web API from the web app dev module. Similarly, using the promise-based programming model, if we have the scenario where the response back from a particular request is a standard data structure consisting of some sort of error message, then this is how you would program it. This is an example of how you would program it using the promise-based approach. So again, we're returning whatever this overall expression returns, and what it will return is an evaluated promise, so to speak. And again, that's, if you contrast that code now with this code, it's slightly cleaner. This is quite messy coding down here, but by default, I'm not sure if Mocha has caught up now, but Mocha is a little bit dated. Okay, it can handle ES6 code, but any kind of more modern JavaScript code like ES7, 8, 9, I'm not sure where we're at now with this ES sequence, but it may not be able to interpret more modern JavaScript. And so that means you have to compile your Mocha code. If you want to write more modern JavaScript within your Mocha files, then you have to compile them back to ES6 JavaScript. Babel will do that for us, but it's just something we need to be aware of. And again, I think I show you in the labs how you can do that. Essentially, Babel does it all for you, but you do have to tell the Mocha runtime to do a compilation before you actually try and execute the tests. And that's it. So today is one of the few lectures where I'm actually going to finish the stuff in time, and I anticipated I would do that because, a lot of the concepts and programming aspects to this are familiar to us from before. The only thing that's really new is this super test library, and you'll get a chance to play with that in next week's lab. I don't think I need to talk my way through the bullet points here. So this week's lab is on Webpack. And having completed this week's lab, you then have all of the stuff that you need to complete the first assignment. The second assignment, which I mentioned there briefly, the second assignment will be to write automated tests and a CI/CD pipeline for the web API that you will be developing for Roseanne as her second assignment. But that's a little bit down the line. Okay, I'm going to leave it at that. I'll pause just for a second in case anybody has a question about what I've covered here. No? Okay, so I'll touch base with you tomorrow morning. We won't need to have a lecture tomorrow morning. I'll just open up a quick Zoom meeting. I'll let you work on the lab, and then you can communicate with me over Slack during the lab if needs be. All right. Thanks for staying with me, and I'll talk to you tomorrow. Bye-bye.
Thank you. Dermot, can I just ask you a question about the assignment, if that's okay?
Sure.
You know the section about doing the continuous assessment where we have to do build, install, and testing?
Yes.
I'm just a little confused. You know, the way we did the CA there last week, and we have like the example jobs and things being built and tested for that assignment, for that CA that we did. How are we going to do it for our assignment? Do we get rid of all that, and how do we do a build, install, and test for the Cypress?
I think you can pretty much reuse the YAML file from last week's lab. You can use it in the assignment because it has all of the stages in the pipeline that you need for the assignment.
Okay.
You will have a different set of Cypress tests, but Cypress tests are just Cypress tests. You can check to make sure that your Cypress tests are working. You can do all that locally before you go near any CI pipeline. Once you have written, well, you don't have to wait, but once you've got some new Cypress tests written for my assignment, and you've got a more up-to-date React app, which you will copy over from the web app dev assignment, you can then run essentially the same pipeline that you did for the lab. You'll be running the same pipeline for the Agile assignment. The only slight difference might be, in fact, no, there isn't a difference. I have the same branching policy in last week's lab as I have in the assignment. I'm not sure if I'm answering your question, Doug, clearly. I wonder.
Yeah, so when we are writing the new Cypress tests and we're committing them to the pipeline, we're still running the install dependencies and bundle app. They're still...
Yes.
They're still running for the pipeline as well, along with the tests once we push them up.
Yeah, it's really the exact same pipeline that you
have.
have
Okay,
in last week's lab. You can just reuse that all over again. That's why we kind of did it in that sequence.
Oh, okay, so we're still reusing everything. Okay.
Yeah. So if you like now, if you're sitting in front of your computer working on this, my assignment, the Agile assignment, the source code will be the most up-to-date source code copied over from your web app dev assignment.
Yeah.
Your E2E tests will be specific to the new features that you have developed for the web app dev assignment. You can run those E2E tests locally on your terminal to make sure they all pass first. And then you can do a git push to GitLab. You're going to have the YAML file, the GitLab YAML file in your project as well. And as I said, that can be almost a direct copy. I don't think off the top of my head, I don't think you need to make any changes. There may be some slight changes. But when you do the git push to GitLab, then GitLab will run the pipeline. It'll do the build, the install, the build, and the running the tests up in the
Cypress
GitLab server.
test.
Yeah.
Okay. Yeah. Sorry. I just wanted to
That's
make
fine.
sure I was understanding it.
You're not the first person to ask me. Some other people have asked me about that on Slack. Yeah.
Okay. Perfect. Thanks for that, Dermot.
Was somebody else trying to get in there? No. Okay. I'll talk to you tomorrow. So.
Thank you.
Bye bye.